In lab, you measured masses and volumes of water in order to determine how the mass of water was related to its volume. Both mass and volume are amounts of material, amounts of water, amounts of any kind of stuff. So this looks at how they're related to one another. In class, you picked various volumes, probably 10 volumes, and for each volume that you determined, you measured the mass using a balance. The volume was measured using a graduated cylinder. You then averaged the masses. You should have had 3, and so technically this would be the average mass in grams versus the volume of water. You then found the slope of your best fit line, and the slope of your best fit line was going to be approximately 1, and I'm only going to make that just a 1 with no sig fig discussion here, because some of you were a little bit above 1, some were a little bit below 1. Okay, this means that the mass to volume ratio, which is the slope, is a constant. We can also say that mass is directly proportional to volume for water. You also found the y-intercept for your best fit line. Y-intercept, or B, was equal to 0 plus or minus a small amount. If you had a large y-intercept, either positive or negative, you've probably done something wrong. 0 is what would be expected. We expect 0 volume if we have 0 mass, and 0 mass if we have 0 volume. If there's no matter, then any measure of it should give 0. But because of finding the best fit line, you will sometimes have a y-intercept, and we will eventually discuss whether or not the y-intercept is significant, or if it can be just discarded or neglected as some sort of result of your best fit line equation calculation. That will be for a later discussion. So your overall equation for the line in the form y equals mx plus b is equal to the following. First of all, y is mass. So we're going to use the symbol m for mass instead of y. X is equal to volume, so we're going to use the symbol V for volume. So that becomes volume my mistake, that becomes mass equals the slope, which was, remember, around 1, times volume plus a y-intercept, which was around 0. Okay. Now, this value, the 1, has units. The units of the slope, since our slope equals y2 minus y1 over x2 minus x1, the unit of the slope is going to be the same or the unit of the y numerator over the x denominator is going to be the same as the y-axis and the x-axis. So y is going to be in grams, x is going to be in milliliters. So our unit actually becomes mass equals 1 gram per milliliter times volume plus 0. Now y-intercept has a unit of the y-axis, since it is the y-axis, and that would be grams. Now this quantity, our slope, of approximately 1 gram per milliliter has meaning. First of all, it can be looked at as a conversion factor to say that for water, 1 gram equals 1 milliliter. We can't say this for anything other than water. All we've measured is water. We'll be measuring some other things. So 1 gram of water is equal to 1 milliliter of water, and that is approximately. It's not exactly equal, but it's close. If I round to a whole number, that's where it's going to be. This value also has a name. We call this the density of water. Density of water is constant as long as we keep certain things constant. The main thing that we have to keep constant is at a constant temperature. We can't guarantee that necessarily in our lab because we spread the activity over more than one day. So there's the possibility that the temperature of the water changed from one day to the next, but it should have been rather small. And with our particular equipment, we probably would not be able to see the effect of that changing temperature. But there is a difference in density as the temperature of water changes. The term density, first of all, we know that we can say that density is the slope of a mass versus volume plot. Secondly, since it's the slope of a line, it must be constant, which means it's valuable. We can use as long as we know the material. So if we know we have water, we can assume that we have a density of 1 gram per milliliter, approximately. And this is known as an intensive physical property. What we mean, well, the definition of intensive physical property is a property that does not depend on the amount of matter. So in other words, if we have a gallon of water, it's going to have the density of approximately 1 gram per milliliter. If we have a thimble full of water, it's going to be approximately 1 gram per milliliter. And if we have a swimming pool worth of water, it's going to be approximately 1 gram per milliliter. Because it's an intensive physical property and because it's a constant, these two really mean the same thing, we can use to identify materials. So if we have a colorless, odorless liquid and we find its density to be 1, then we can make a good guess that it's going to be water. We might want more information, but the density would be a major identifying factor since it is an intensive physical property of a material. Also, since density is the slope of a mass versus volume plot, we generally can write the density of water or density of any material as D equals n divided by v. And again, this is slope equals the y variable divided by the x variable. Very important equation in chemistry.